Good morning, advanced algebra students. I hope you are doing fantastic. I'm excited about starting the next chapter in advanced algebra. We're actually going to review, we're beginning chapter 1 in the advanced algebra book, but we have one more algebra 1 section to do before we can realistically do that. And interestingly enough, it is from chapter 5 of algebra 1, section 1, and it is on graphing absolute value functions. The reason that this will be helpful to us is that in the chapter 1 book of advanced algebra, they're assuming that you know how to graph parabolas and absolute value functions. And much of the vocabulary that is discussed in the context of absolute value equations and parabolas. And many of you probably have not graphed either of those. And so I wanted to give you a little bit more background information to prepare you for the first chapter of the advanced algebra book. So again, this is section 5.1, the absolute value function. Now, some of you may even be wondering, what is an absolute value function? An absolute value function is something in the form y equals the absolute value of x. So if we did a t-chart, for example, of that, we might plug in -2, -1, 0, 1, and 2. Now, do you know what absolute value means? Absolute value means distance from 0, so it's always positive. So if we ask ourselves, how far is -2 from 0, the answer would be 2 spots. So we would fill in the t-chart accordingly. When we graph the basic absolute value function, we get a V-shaped function. The parent function goes through the origin and it makes a V shape. I probably should have used a ruler there, but hopefully you get the idea. All right, now we also need to understand the basic setup of an absolute value function. So the more complicated way of writing an absolute value function, this is something that does not necessarily have a center at the origin and have a slope of 1/1, is y equals a times the absolute value of x minus h plus k. So this is a format that would apply to this whole lesson. Y is on its own, and then this hk here represents where the vertex of the absolute value function would be. So we can write h comma k is the vertex. Now in the example that we just did, h and k were 0 and a was 1. So that's why we just had y equals the absolute value of x. However, in more complicated examples, we can move away from the origin. So what happens is that h tells us how much we need to shift left or right from the origin, and k tells us how much we shift up or down. So if we're not having a vertex, that would be the vertex right there at the origin, and it's at hk, h tells us left or right from the origin, and k tells us up or down. Now, there is another thing to note here, and that is what a is. Now, informally speaking, this is the slope of the right-hand side of your absolute value graph, the slope of the right-hand side. We also know that if a is positive, the parabola will open up, and if a is negative, the parabola will open down. I'm super excited that you guys are doing these notes, because there's no way we're going to be able to put all of this on a crib sheet. Another thing to know about A is if it's a fraction between 0 and 1, it will shrink the parabola, and if it is greater than 1, it will stretch it. That's a little bit much to put there, and we can always address that later. But I wanted to make sure you had the basic parent function for absolute value and then the more complicated version here. So let's go ahead and do some examples of how we can use this information to see a variety of absolute value functions. So I'm going to give you 3 steps to graphing. Steps to graphing an absolute value function. The first step is going to be to plot the vertex, which is h comma k. The second step is going to be to move from the vertex according to the slope of the right-hand side. According to slope of right-hand side. And the third step is to draw the rest of the V symmetric to the first half. Okay, so let's do an example here. Let's go ahead and graph example 1. Y equals the absolute value of x minus 2 minus 3. Now, something that we need to keep in mind, and I'm going to write the formula above this. Something that we need to keep in mind is that the formula has a minus sign built into it. It says x minus h, and you can also think of that as x plus the opposite of h. So if you look carefully at the equation that I've just given you, you can see that h is 2 and k is negative 3, because the formula says x minus h. So if my equation says x minus 2, I know that h is actually 2. So step 1 is to plot the vertex. The vertex on this graph is going to be 2 over and 3 down. So that is step 1. HK is 2 comma 3, and I can label that. Step 2 is to move from the vertex according to the slope of the right-hand side. The slope of the right-hand side is A. In this case, it is just 1 over 1. So what we do is we go up 1 over 1 from the spot that we're at. So we go up 1 over 1, up 1 over 1, up 1 over 1. And that gives us the right-hand side of the V. Then step 3 says to draw the rest of the V symmetric to the first half. So I would go up 1, back 1, up 1, back 1. And draw that other half there. So that's how you graph an absolute value function. Let's do one more. Example number 2. For example number 2, we're going to graph y equals 1/2 times the absolute value of x plus 2. And you can think of that as being plus 0 if it helps you. All right, you tell me, where do you think the vertex of this is? Where would be the vertex of that absolute value function? Hopefully you said -2, 0. So we plot the vertex there. Now, the slope of the right-hand side in this case is up 1 over 2. So I'm going to go up 1 over 2 and put a dot there. And I'm going to draw the right-hand side of my V. Then step 3 is to draw the left-hand side symmetric to the right. So I'm going to go up 1 and then back 2. There you go. There's your graph. All right, let's go ahead and do another example. Let's call this example number 3. I believe there's one like this in the homework. And to be honest, it's a relatively simple problem, but if you haven't seen one yet, it can be kind of confusing. So example 3 says to tell whether each point is on the graph f of x equals absolute value of x. If it is, give the coordinates of another point with the same value. So let's look at the point Q, which is at 4, 4. And the question is that on the graph? Well, we're looking at y equals absolute value of x, and so we want to know, is 4 equal to the absolute value of 4? It is. So we can say yes. Then they would like another, the coordinates of another point with the same y value. So the graph that they have just given us with the point 4, 4 would be on y equals the absolute value of x, right here, at 4, 4. Another point with exactly the same y value would be negative 4, 4. So we can do another example of that during homework. So that would be example number 3. Now, let's talk about how to write an absolute value equation. And we'll make this in just a moment. We'll do example 4. But the steps to writing an absolute value equation. To write an absolute value equation. First, we're going to make a note of h and k. We do need to know where the vertex is in order to know how to write the equation. Then we need to find the slope of the right-hand side. And then the last step is to plug all of that information in. So plug in h, k, and a into y equals absolute value of x minus h plus k. Oh, and we need the a there. Y equals a times the absolute value of x minus h plus k. All right, so let's take a look at example number 4. It says, write the equation of the absolute value function with a vertex at 0, 2 and passes through the point 2, 3. Okay, so let's go ahead and figure out how we would write the absolute value equation for that. It can be kind of helpful to visualize this when you're writing the equation. So we can graph that parabola with the vertex at 0, 2, and we can make a note of the fact that it goes through the point 2, 3. All right, step 1 was to make a note of what h and k are. They gave us the vertex, so we know that h is 0 and k is 2. For me, I just like to label the point because I think it makes it a little bit easier to notice. Then we need to figure out what a is by counting the slope. We notice that we're going up 1 and over 2. So our a is 1 over 2. So now that I know h, k, and a, I can write my function. Y equals 1/2 times the absolute value of x minus 0 plus 2. I can simplify that to y equals 1/2 times the absolute value of x plus 2 if I want. Okay, last example. Example number 5, and then we'll be done. You guys have been really diligent, and I appreciate that. I believe there is one like this in the homework as well. It says a bus is traveling between two cities that are in neighboring states. The graph shows the distance of the bus in miles from the state line. So I'm going to show you a picture of the graph here. This is a little harder to do, obviously, than if I was able to give you paper notes. But we're going to skip count by 15s on the y-axis. So I can mark off 15, 30, 45, 60, and so on. This would be 75. And then on the x-axis, we're going to skip count by quarters. The y-axis is distance in miles, and the x-axis is time in hours. So let's see, we're going to mark off every 0.25. So I've got 0.25, 0.5, 0.75, 1, 1.25, 1.5, 1.75, 2, 2.25, and 2.5. Now, there is a point at 0.75, at 0.25, 60, at 0.5, 45, at 0.75, 30, at 1 over and 15 up, at 1.250, so let's go ahead and draw that. Oops. Then another point at 1.515, at 1.75, 30, at 245, at 2.25 and 60, right here, oops, there we go, and then at 2.575. I know that really is a pain to draw. So, the question says, what does the graph tell you about the bus ride? So, the graph tells us the distance that the bus travels. It is 75 miles to the state line. Because if we're looking at distance from the state line, the bus is starting off 75 miles away, and then it becomes 0 miles away, and then it travels 75 miles back. So the distance is 75 miles to the state line, and then we add on another 75 miles away from the state line. For a total of 150 miles traveled. The rate that the bus is traveling is 60 miles per hour. And we can get that by doing distance over time. The distance was 150 miles, and the time that the bus was traveling was 2.5. And that works out to 60 miles per hour. All right, we're all done with the notes. Good job, you guys. I know that was a lot of work. I will see you in Zoom. Bye.